Hi everyone, I'm NeepFX, but you can call me Nicolai, and today it's going to be you, me, and Java language architect Brian Goetz, with whom I talked during my 25-hour live stream back in May. I want to start this video off with a quick word association game. What are your reactions to the following terms? Primitives, serialization,
Default mutability.
default nullability. If you're like me, your reactions haven't been all that positive, which is unfortunate because, of course, Java has all of this. So naturally the question arises why it has these annoying properties and how much more successful it would have been without them. Let's see what Brian can tell us about this.
I found some nice words to describe your role, I think. What was it? Creator of lambdas and streams, bringer of war and switch expressions and records, harbinger of pattern matching, reinvented serialization and value types. Is that about right?
Yeah, that's a pretty good list. My official title is Java language architect, and so it is theoretically my job to chart out the future direction of the Java programming model, which is no small job. And I've been doing this specific role for probably 6-7 years, and lambdas was the first big project I did. So talk about trial by fire.
Well, could have been worse. Could have been modules. Not commenting on that, I see. So when we met a couple of days ago to have a quick discussion, and already said back then, there's so many things that we could be talking about. First and foremost, I could ask you all my questions about Amber and Valhalla, and you could talk us through all of that. But those sources are, most of that information is available. It's not always ideally searchable, but if people are interested in that, they can look that up. Of course, your personal opinion on that is quite valuable, but I think there's other stuff that we can talk about as well. And what I want to talk about was after watching, when I started watching conferences, it was just like, okay, there's people that are talking about whatever is new in Java, whatever is new in that framework. And the Ask Me Anything sessions with the Java architects, they really stand out in a way that, well, these are the people who work on the underlying language, and you can just ask them about why is this feature like this and why is that feature like that, and then you can see sometimes people squirming or answering through clenched teeth or not at all. But mostly it's fun and games, and you can get a lot of information, like a lot of insights from that is otherwise hard to come by. And by watching these, I realized that there are quite a bunch of features that not everybody is totally on board with how they still are in there. And I think the first and foremost one is serialization. To me, that was always just some annoying thing that is in Java that I don't care about, but it was your presentations on Lambda and then later other presentations and the AMAs that gave me the impression that serialization is not just something that is there and tends to be annoying. It's actually a problem while further improving the platform. And then, of course, the question is, well, then, how would your language look now if you could just do whatever and then you would not have serialization? And what else would you not have and what else would you have? But once again, I can have that conversation with pretty much everyone because everybody has their opinion on that. So I settled on why do we have serialization? And if we have it now, was that necessary back then? Do you think it was a good decision? For example, serialization. Do you think was a good decision back then? And what do we do about it now?
Yeah, so this is a great question because on the one hand, serialization is everybody's least favorite feature, right? When people ask me, what feature do I most regret? Serialization is the easy answer. And my buddy Stuart Marks has described serialization as a full employment act for vulnerability engineers because it has been the source of so many security issues. And in effective Java, Josh says, avoid serialization. So everyone loves to hate on serialization. So where does this come from? And there's a tension here because on the one hand, the concept of serialization is a totally sensible concept, right? That you need to store documents on disk or in databases or send them over the wire. And serialization is a way of taking an object graph and turning it into a linear stream of bytes. And that's a valuable thing to be able to do. And in fact, I suspect that Java would not have been successful without it because where Java was initially successful what was, on the server side, we had distributed object frameworks like EJB or RMI, and serialization was essential to being able to make remote method invocations from one system to another, because if you wanted to pass an object, it just got serialized and sent over the wire. So the concept is essential. I think it was an important part of the platform's success, but the deal with the devil that we made in 1997 was we implemented it in a horrible way. It was completely nailed on the side. It's completely extra linguistic. And so it exists outside the language and outside the object model, and this is where all the evil comes from. And so it undermines encapsulation, and it makes it hard to evolve things, and it makes it impossible to reason about security. And the comment during Lambda, during the Lambda project, we spent, I don't know what percentage of our time, but it was well more than zero, dealing with serialization and how do you serialize Lambdas, and there were no good choices. And so it's an ongoing tax. Every new language feature has to deal with it. And so it was a good idea that was implemented terribly. And now here we are stuck with it for the next 25 years.
So to talk about that extra linguistic character a bit, so for those of you who don't use the serialization daily, I mean, you can just slap the serialization ID on there and then everything just works or not. But the things like if you want to interact with that mechanism, you have to implement some classes which nobody tells you, methods which nobody tells you are there. The documentation tells you, but there's no interface that tells you that or something. So that's really weird. Like it goes around the constructor and that kind of stuff. Do you think, like when you said it was implemented in a horrible way, did you back then see that this would be valuable, or not you personally, but did the team back then decide that this would be valuable and important when it just didn't have the time? Because sometimes it's like short messages, right? From what I know, short messages were basically tacked onto the site because, hey, we got some free bandwidth left over. And it turns out this is the most used feature of mobile phones like 10 years later.
Right.
Which one was it? Like, is it like, do you think like better decisions could have been made if you would have foreseen how important this becomes?
I think so. Now, I wasn't on the team at the time. I was a Java user at the time. And I remember...
You're one of those people now.
I came here honestly. I remember when it was added to the platform, I remember looking at it and saying, okay, I see the benefit. Boy, this mechanism is pretty fiddly. And, when I talked to people who were there at the time, there was clearly a internal battle within the company where there were business goals of we have to get this out as quickly as possible, and it was at a time when things were changing very quickly and there were a lot of fingers in the pot, and so I think the wrong idea won, in a sense, that it was not so much that people didn't agree that being able to make remote method invocations was important, but people didn't agree about the mechanism, and the mechanism was problematic. And so it was a decision that looked expedient at the time, but we've been paying for ever since.
Yeah. So I think one aspect, by the way, when you talked about that this was hard for implementing lambdas, is it feels like serialization and lambdas, which are actions, should not have any relationship at all, because you serialize data, right? Why would you serialize actions? And the first time you start serializing actions is when you deal with swing, where you also listeners are serialized, and you wonder like, but why is this is not a thing? It's a process, and so the question is also in chat. Maybe is it just serialization that's considered annoyance, or just thing related to the serializable interface? What about externalizable? Is it just as bad?
So externalizable was not as bad because the programmer was in control of what the external form was. So it was harder to use, but it was less magic, and the magic is where the sin was, right? So, and if you look at the historical context, I mean, if you go back, imagine you're a programmer in 1995, and 12. Object. What's that?
I was 12.
Okay. So let this old man tell you about it. In the mid '90s, objects were going to save us from all the complexity of the world, And, if you look back to what we had to do in the 80s to implement persistence, it was always this very painful thing. So imagine you have, you're writing a word processor and you have your document has an in-memory structure, this big complicated network of C structs, and you have to save the document. Well, you have to write some code to deal with every single struct in the document, and that code has to completely understand how to navigate the document correctly, and you have to keep it in sync with all the other code that's mutating the document as you add features, to your word processor. And if you get any of this code wrong, which is like really boring code to write, then you're out of business, because if your word processor can't save documents, then your program is worthless. So one of the many big promises of object orientation was you get this automatic persistence that because there's reflection, we can reflect over the structure of your graph and serialize it mechanically. And that was amazing, right? That was like, all of this like horrible, low value, fiddly, error prone code just went away. So it was kind of hard to say no to that. But, as you highlighted in your in your marketing with the comment, today's problems come from yesterday's solutions. This was a yesterday's solution to a big problem from yesterday, but now we have a different problem today.
So you said basically what you're saying is like the magic was important though, right? So it sounds like the magic, without the magic, it would not have been successful. So just externalizable would probably not have cut it.
Right, because externalizable was still harder to use. You had to write imperative code to say, go get this out of the object and write it to the stream, and then go get that and write it to the stream. And then you had to write the opposite code for reading it, and you had to get it in exactly the right order. So it was fiddly and picky.
Yeah. So you said like the magic's required, but then are you saying like the magic could have been done better? Like if you would sit down today and somebody said like, okay, you have to keep serialization working somehow. You cannot back out of it. You still have to keep it. Just like, but you can work with the magic. Like how would the magic be different?
So what I think is necessary is to bring it into the object model. So if you're writing a class, you spend all of this time thinking about what's my representation, what's my API, what invariance am I promising to the user, and one of the things that you should be thinking about is what's my external form, and is it the same as my internal form or not, right? So some serializable classes, their external form is just scrape the fields and send them to the stream. But for say list or map, the external form doesn't take the in-memory representation and send it to the stream. It says, I'm just going to take the elements and send them to the stream. And then at deserialization time, I'm going to make an empty map and I'm going to insert the mappings into it. And that is a design decision that we want to allow programmers to make, which is to say, they design their representation, they design their API, which may or may not look just like the representation, and they have to design their external form, which again may or may not look like their internal representation, and then hopefully write the absolute minimum amount of code to be able to go between the internal and external representations. And for example, we can use features now that we have now or will have soon that we didn't have then to make that easier, like pattern matching.
Yeah. So with records, for example, when there's talk about revamping serialization under for records, right? Is that a thing that I understood correctly?
Yeah.
And records, because records have a very natural, because the API is the API is the state, the whole state, and nothing but the state. Will you also allow people to have a different internal and external form, or would that just be you opted for a record, you basically agreed that you don't have control over your API, it's just one-to-one?
Yeah, so for records, we have this design assumption that says the record has a state description. It's the thing that comes right after the class name in parentheses. And we're going to derive everything of interest about this class from this single state description. So we're going to derive the construction protocol from that. When we have deconstruction, we're going to derive the deconstruction protocol from that. We're going to derive the equality protocol from that. And if you say implement serializable, we will also derive the serialized form from that. But the thing that's different about records than just an ordinary class that uses default serialization is we're able to use a trick that we would like to make available to all classes, which is we don't have to bypass the constructor.
Mm-hmm.
So the role of constructor is to check the arguments and make sure you don't create bogus objects. But serialization bypasses the constructor. So, anybody who can create a binary stream with bad data can, create a serialized object and then deserialize it and create an object in the wrong state. And in order to defend against this, ordinarily, you have to do a lot of really difficult work, and it's like playing whack-a-mole. It's like, the worst security environment you can imagine. But with records, because we know the construction protocol, the serialization library says, oh, you're deserializing a record. I've got the serialized form off the byte stream. Great. Before I write those into the fields, I'm actually just going to call the constructor.
Mm-hmm. Yep.
And if the constructor says illegal argument exception, then it won't create the record. And so this is adding back a little bit of safety to serialization, where at deserialization time, it's going through the constructor, and the constructor can check the arguments, normalize the arguments, defend against bad data, etc.
Mm-hmm. We have a question that relates to, actually, the 2 comments on serialization. There was one that, so this brain wrote 2 things. The biggest mistake with serialization, in my humble opinion, the ability to serialize circular graphs. And another thing is the serialization proxy pattern breaks cyclic graphs. Because the serialization proxy pattern is probably it's too much work to be reasonably done over entire code base. But for specific classes, it's actually the best thing you can do with serialization, right? You just implement the serialization proxy, and there's that.
And if you ask why was serialization so awful, whenever something comes out wrong, you want to ask the question, well, what requirements did they believe they had?
Yeah.
Right. And one of the requirements that they decided on, for better or worse, in 1997 was you should be able to serialize any object graph. And that included cyclic object graphs.
Yeah.
And so there was no organized way understood to handle that other than what they did, which was scrape the fields and slam them back in on the other side. And if you step back and ask yourself, how important is that? You realize that, well, if serialization is for data can generally be rendered into an acyclic form, even if its internal representation is like a doubly linked list or something. And if they had accepted a lower set of requirements, they could have done something much better. And when we're looking at fixing in air quotes, fixing serialization, part of how we intend to accomplish that is to say, you know what, serializing cyclic graphs was just a bridge too far. And if you don't take the requirement to serialize cyclic graphs, then you have more flexibility on how to implement things.
And the other thing is, I think, why can't you just that you can basically serialize anything, that there's no sensible requirement that the language has except for a serialization ID to what you want to serialize, right? That there's no, as I said, like there's so many things that are like, for example, when you work with when I started working with Swing, before I really understood what serialization is, to me it was just an annoyance by my IDE having to put that ID everywhere, because I was not even like, I know why it's there in Swing now. Maybe it was important for Swing, I can't really say, but it feels weird that you can serialize so many more things than just data, and maybe limiting that would have helped, like somehow creating a subset of things that you can serialize.
Yeah.
The next question brings us to nullable types, where there will be in the future. Once again, instead of looking at the future, maybe we can answer that there as well. But I want to look into the past with null. Null, to me, is a pet peeve. I hate null with a passion. I think like using optional everywhere is an okay-ish solution, leaving out the annoying fact that no API gives you or very few APIs actually give you an optional. So that's a bit annoying. But more modern languages or newer languages, like for specifically Kotlin, they didn't invent this, right? But Scala did the same thing as far as I know. With putting null into the type system, it just to me feels much better. Because my main problem with null is always you don't know whether it was allowed to be absent or there's an accident that it's absent, and tracking that down is so much more work than actually fixing it. So to me, with my very limited non-existent language design skills, it looks like, well, null was just I heard somebody say it's an expensive mistake. I once heard a number on that, and maybe it should just never have been this hole in the type system. Back then, do you think that was when Java was created, was that a common thread among language designers, that maybe we should have or just normal, like you just have null, let's just deal with it? Or do you even think it was important, maybe because C and C++ had null, and then we have to have it too?
Yeah, I think it's important to look at the environment in which Java evolved, right? So the Java effort, got started for real around 1992. So in 1992, there was basically one programming language that you were allowed to use for any serious work, and that was C. There was really almost no serious commercial work being done in anything other than C at that point in history. And so the audience, I mean, if you have a new programming language and everybody else is using C, well, 100% of your audience is C programmers.
Yeah.
And if you want to attract them over, you have to appeal to them. And so there were a lot of C-centric assumptions made at the time. And one of them was, well, yeah, null is a fact of life. Pointers could be 0. And, it was not taken seriously as a type system concept for probably a good 10 years later. And you're right, a lot of Java-like languages are experimenting with that now. C#, Scala, Kotlin, a lot of the interesting work around what are called cardinality-based type systems, where all the nullable typing came from, was done earlier. There were several really interesting experiments that came out of Microsoft. One of them was called C Omega. And a lot of the ideas from that actually went into XSD, the XML, XSL, the XML style sheet, XSL transform language. Its type system was cardinality based. So there was some interesting work done on cardinality based type systems where you had base types like int and string and what have you, and then you had cardinalities, 1 or 0, that's optional. 1, that's exclamation. Star, that's 0 or more. Plus, that's 1 or more. And these language, this mechanism lends itself very well to document processing. You can imagine if you're transforming an XML or HTML document, you want to be able to say, I'm expecting 1 or more of these things, and then do it for each one of them. And you want to be able to flat map sequences. And so that fit in very nicely with that use case. Where we have a problem is not that we can't add the question mark and exclamation types to Java. We totally can. The problem is there's
let's just not blow past that. Maybe that I think you're coming up with problems like whether it makes sense. But is it really that easy to add that? Or would then every default type that we have now becomes a question mark type effectively, right?
Right. So let me back up. It would be easy to take the Java type system and add nullability to it.
You heard it here first, folks.
The problem is there is already some Java code that's been written in the last 25 years, and none of it is ready.
Yeah.
Right. So now every time, if you were starting over with, and you were willing to say everyone has to throw out all their Java code, and we're going to refine the type system, and you're going to have, string question and string exclamation. and there's going to be a conversion, exclamation as a subtype of question and all of that. That's easy enough to do. The problem is you have all this code out there that just says string. And what do they mean by that? And where am I supposed to give you warnings when you when you cross boundaries? And so the effort of going through even just the base module in the JDK and annotating it correctly for, does this thing that it return, is that a question or an exclamation, is a tremendous amount of work. And for any interface, well, we don't know where all the implementations are. So unless the spec was already very careful to say never returns null, it's the sort of thing that is easy to do when you have no customers. And once you have a large base of code out there, is much, much harder to do. And so retrofitting it, very, very difficult.
Yeah, I mean, that's basically what you're just describing is just a bigger scale problem with what we already had with optional, right? Like even like optional, you should return optional where returning null is error prone. That's, I think, is the official guideline. Well, map.get would be a stellar example, but you cannot just put optional there. And it's the same thing with the question marks. Well, actually, question marks you can design it in a way that's not just a plain compile error, but as I said, that the only thing to map a string to, I guess, is a string question mark effectively. Like that's the only thing you can really do. Yeah. So maybe Java should have a strict mode then.
Well, and in fact, that experiment is being run right now in the C# community. So one of the great things about Java's conservatism is we get to let other people do the experiments, and the ones that work, we say, great idea, we'll take that. And the ones that don't work, we say, boy, are we glad we didn't do that. And so in the C# community, they are doing a similar sort of thing where they are treating an unadorned type as kind of the same way we did with raw types in generics. That it could be either question or exclamation, I don't know, and you get a warning. And they give you warnings at boundaries when you go from one module to another, and you can compile certain modules as, I want to compile this module in strict mode. And then you get better error checking within that module, but at the boundary between a strict and a non-strict module, things can happen. So just like with generics. And so they're doing that experiment, and we will see how it works out.
So isn't Kotlin basically doing something similar with their platform types?
So Kotlin is, has the advantage that they opted for a lot of these language features before they had any users.
Yeah, no, but when they interact with Java types, when they interact with Java types, they use the platform types to basically say, like, we don't know really.
Yeah, right, exactly. They treat non-Kotlin types as of unknown nullability. Yeah, and they try to guess about what the what the direction is. Yeah. So the fellow who's asking, couldn't there be a mode? Couldn't there be a strict mode where you rebuild everything from scratch and then you get stricter type checking, right? And the same question, this same fellow probably 14 years ago asked the same question if he was programming Java at the time. Couldn't I get reified generics if I did that? Right, because the answer to almost every one of these, why can't we have this modern WYSI thing, is, well, because there exists old code out there that doesn't know about that. And so how did we get erased generics? In part, we got it because we wanted compatibility with pre-generic code. Why can't we have optional types now? Well, because we want to have compatibility with the billions or trillions of lines of Java code that are out there. And so it's a very common question for folks to ask what this fellow is asking, which is, well, what if I was willing to recompile the world? And in theory, that would be possible, but there's probably almost nobody who meets the requirement of, I'm not using any code that was written, more than 5 years ago, because everybody wants to use some library, from Maven Central or what have you. So the number of people who could benefit from that would be very, very small. And so maybe in 10 years, we have a chance of migrating more of the ecosystem in the right direction. But it takes a very long time for old code to be purged from the ecosystem. And I claim that that's a good thing, right? That one of the great things about the Java ecosystem is there is an awful lot of code out there that was written 10 or more years ago that people are still using because it still works. Mm-hmm. And because we haven't broken it. Right, and so part of our obsessive focus on compatibility comes from the fact that if you invested time to write some Java code, we don't want to invalidate that investment by changing things such that it doesn't work.
Yeah, and I think I don't say warps. That sounds too negative, I guess, but that shapes a lot of features. Then, right? I mean, starting with generics, as you said, like with erasures and raw types, how they interact. Just today we use something like sneaky throws or stuff like where you abuse the generic system for its weaknesses that were introduced to get that compatibility. The module system has a clear migration path that works. I think was reasonably well. But the point is, the module system would probably look different if if Mark Reiner could just flip a switch and everything out there would also be a module. That would make so many things easier. I'm not sure about lambdas, actually. They seem to be fairly, to me at least on the outside, serialization aside, fairly uninhibited by this specific problem. No? You seem doubtful?
Well, so I'm glad to hear you say that, because we did work very hard in order to make lambdas actually forward compatible with old code that didn't know about lambdas.
That is really cool, by the way. Yeah, it is. Like just being able to, well, there's this tendency, what was it, AWT, to have a listener which implements like 20 different listener methods. So that's unfortunate. But many other things, like particularly listeners or like stuff like runnable, that just worked. And that's really amazing that you could just like have this kind of forward compatibility. But my impression was, at least from your talk from Lambda Under the Hood, that that was more of a byproduct of realizing that proper top-level functions, first-class functions, are not actually that easy to implement. And that, well, maybe as far as I understood it, that was your first choice, going with first-class functions.
Yeah, and that was the point that I was getting at, which is that there was a trade, right? That we got a bunch of good things. We got the ability to run on the VM we had. That was important. We got the ability to interoperate with old code that had defined abstractions like listeners or runnable. But what we didn't get was first-class function types, and that's a cost. That definitely has a cost in terms of people's abilities to write certain kinds of libraries. And so it was a trade-off for compatibility with the JVM and compatibility with the world of libraries that we had, that we made the choice to use nominal function types. And I think it was the right choice, but there was still a cost to that trade, and we should be aware, that we paid that cost, and and it's not a cost that will go away, right? But I did, as you mentioned, the Lambda Under the Hood talk, I think the big thing that people don't realize when they ask, well, why didn't you do structural function types, ignoring the technical issues of whether it was practical or not on the JVM, is if we had done that, what we immediately would have done was bifurcated the entire ecosystem, where every library would now either be an old library that used nominal interfaces, or a new library that used function types. And there would be this multi-year, maybe decade-long migration and interoperability challenges between the old and new ones. And so I think it was a good move to go with nominal function types, but it did have a cost.
Yeah. So actually, I want to ask that question, but now it actually got answered in chat. So what exactly a first-class function is and how that would look different. But it basically means that the compiler knows which functions exist, and you don't have to have assign it to something that is a predicate or a function or whatever.
Yeah. So statically typed languages are generally divided into two camps: the nominally typed languages and the structurally typed languages. So a nominally typed language means that every type has a name. So Java is nominally typed. You create new name types by saying class foo or interface foo. And with the exception of arrays, which are structural, right? Because you can take foo and make array of foo just by putting brackets on it. Java is almost entirely nominally typed. Other languages are structurally typed. Their basic types are tuples and sequences and maps. And rather than building new types with names, you just build up map, tuple of, map of, list of, but not list list. I mean, like square brackets list. And there are not very many examples of languages that have successfully combined nominal and structural typing. And so even though structural function types, which is to say if int is a type and long is a type, then function from int to long is automatically a type. That's structural function types. That's a very sensible and sound thing. It's the basis of the lambda calculus, but it's not a very good fit for Java. It would be something that would be nailed on the side of Java's type system, and there would be all kinds of interactions between nominal and structural types. And so by sticking with nominal types, not just for lambdas, but also for records, right? Records are tuples, but they're nominal tuples.
Yes.
We could have done structural tuples, but instead, by using nominal tuples, it fits more into how the language thinks about types.
Yeah. But Lucas Eder would have been very happy though.
Yeah.
He always asks for that. So maybe I don't want to repeat basically the same conversation over and over, but a couple of other aspects there. For example, the same thing I asked about nullability basically. Like, was it back then considered a big deal? Where I said like basically no. Like the fact of not having null as just a hole in the type system, that could be a good idea, didn't really, come up until a couple of years later. Another thing about that this is mutability. Everything is mutable by default. Then, you can make stuff final, but, that's not only an extra cost in having to put it there, it's also annoying as hell to read. Particularly, I'm okay with it on fields, but I have a colleague, or I had a colleague rather, who had his Eclipse configured in a way that it would add final basically everywhere where it would be possible. So he added like a method to a class, and you get back like a huge diff because final now is in front of every variable declaration, also in front of every parameter. And while I, in spirit, agree with where he's going with that, I think this kind of not being able to reassign that stuff is great. It's just so much clutter. Once again, was that a thing back then? I guess because immutability, strong focus on immutability also comes with performance cost. And I guess Java, when it started, did not exactly have a huge performance budget to spend on things that C programmers wouldn't, even without a performance cost, probably not appreciate a whole lot. So what about that?
Yeah, so it is kind of amusing to note that Java managed to succeed despite having gotten almost all the defaults wrong, right? That references are nullable by default, that fields are mutable by default, that the default visibility is not private.
Yes,
that classes are extensible by default, right? So we got all the defaults wrong, and yet still somehow Java was a successful language and people still want to program in it. And of course, these are very difficult decisions to change. So we are kind of stuck with them. But you're absolutely right that, if you're trying to appeal to C programmers in 1995, immutability is a very unnatural thing. Most C programmers, they know what const means, but it wasn't part of the programming culture at the time, unless you came from an academic background and you had programmed in functional languages, which had a very small following at the time. It was not, if you look at the pain that C programmers were in, right? If we wanted C programmers to switch from C to Java, we had to offer them something, right? So what did we offer? We offered garbage collection. That's really powerful. What kind of pain were C programmers in the early 90s? Memory management was awful. 90% of bugs were memory management bugs. So if you could offer someone a programming model that was C-like enough, but you never could make dangling pointer bugs or double freeze, that was a very powerful thing to offer. In terms of immutability, nobody thought they wanted that at the time. And, it's become much more part of the culture now that we've all learned, make things immutable unless they need to be mutable. But how do we learn those things? We learn them by making mistakes, getting our fingers burned, and realizing, that couldn't happen here if I had done it this way.
Yeah.
So I think it's taken a long time for the programming community to come around to believing in immutability enough that they would accept it as a reasonable default.
Yeah. So by the way, there's a bit of disagreement. People saying like, no, it's not that bad actually. So for example, what was that? Just saw it. Stuart Marks said, back in the day, having string be immutable got a lot of hate from C programmers. Okay.
Yep. It did.
Java successful because the defaults were not wrong, somebody says, and somebody else says, I agree, practically the defaults were not wrong. The question is wrong in what sense? Like, that's what discussion is about, right? We also talked a little bit about this earlier today with Kevlin, who said, well, what's wrong, what's right changes over time, right? In what context was it right and wrong? And that's what I was going for. Like, even if we sit here today and feel like, well, this is all just stupid. Even if that were the case, and of course not everybody agrees, there's a lot of people out there. Like, for example, the whole try to do stuff, write immutable code. I think that's a good thing to strive for, but I see myself in a very loudmouth, but still minority of this, right? Most of the people I work with, they say like, but now I have to get my stuff done and I'm going to just write mutable code all the time. So even now, it's not like it's settled that mutability is bad, meaning 9 million Java developers now agree and try to write immutable code. So even now, it's not sure whether it was wrong or not, at least not by public opinion. But back then, of course, specifically again by public opinion, it probably would have been wrong to say like, okay, please come to our language. By the way, you have to learn these 20 things.
It would have been unrealistic. Yeah.
Yeah.
I think it would have been too much to ask. And one of the commenters in chat said, Java was successful because it didn't get the defaults wrong. And I think what they mean there, and I would agree with that in that sense, is that a lot of programmers are very comfortable programming in an imperative style. And Java was friendly to that. Mm-hmm. But what it did was added in memory safety and type safety. And so you could program in this comfortable, easy, maybe slightly undisciplined imperative style, but you at least had the memory safety and the type safety of the system working for you. And you had, in addition, all of these platform features like threads were built in. That you didn't have to implement your own mutexes. So you had reasonable concurrency primitives, you had reflection, you had all of these nice things in a imperative language that gave you more safety.
What is your stand on primitives? Like, I'm not even sure how it is today because it feels like it's very odd within the type system. They have this, what are they, like 8 or 7 or whatever, things that are just different. Also, probably not entirely coincidental, they're really like useless in most high-level domain code, right? At some point you have to get down to them. You have to get down to chars and ints. But in the most code you write, you want to do that as late and as little as possible, really.
Mm-hmm.
At least that's the way that I write it. So do you think that because other languages just don't do that anymore, that they don't have these specific types for primitives. You just have a number type and a number, like Java, right? Basically, you just have number, maybe you even have long and float, but just the uppercase classes, and there's that. And of course, I mean, we see that with generics, we see that with boxing and unboxing. It's not like this has not come at a cost. Do you think just foregoing primitives in today's languages is a useful approach, and do you think would have been one back then?
Yes to the first question, no to the second. So, 25 years ago, it was it was an ugly compromise that you had to make, because if you tried to model everything with objects, then programs that tried to do something as simple as adding up a bunch of numbers would just be too slow. And so I think it would have been a non-starter in 1995 to try to have a language that had no primitives. And part of the reason for that is, and it goes back to one of your earlier questions about the performance context of the time, in Java 1.0, language was interpreted. Mm-hmm. Now, it did not take very long for the JIT compilers to come along, and the design of the JVM was deliberately structured the way it was because it anticipated that JIT compilation was coming down the road. But if you had to interpret your way through a virtual method to do every addition, people would not have taken Java seriously. So in 1995, it was a forced move. But like many of the other things that we've talked about so far, it might have been essential to the success of the platform, but it's something we're paying for now. And even as recently as, a few years ago, look at streams, right? The most painful part about doing streams was in stream and long stream and double stream. And not only was it yucky from an abstraction point of view, not only was it annoying to do everything 4 times, but the ability to have multiple types of stream constrained the design quite a lot. But we knew that without being able to have a sum method on in-stream, we were dead, right? No one would take it seriously as a programming model. So, this is something that, even quite recently has had a significant cost. Could a new language being designed today get away from primitives? Absolutely, because JIT technology has improved by orders of magnitude in the last 25 years. And so, the compiler, we know now what we didn't know then, which was how to compile away all the abstractions so that they have no cost.
So it's not just a difference. It's not just a difference you say in different hardware. So, but it's also we say a difference in just what we know how to do now.
Yeah.
Oh, okay. I was always aware. Well, of course. I mean, JIT gets. Yeah, actually, it's kind of a stupid question because JIT gets more and more sophisticated. But I just thought it was mostly a matter of doing. But what you're saying, no, it's not just the doing. It's actually just knowing what to do and where to do it.
Yeah.
Okay. Yeah. So, but that's then we basically said that. So I don't want to ask you about really like your ideal question, but ideal language. But that means that you would if you would design language today. It would make quite a lot of different decisions from Java back then, because I mean you now clearly see with other languages that are around now that some of the things that we with Java programmers tend to complain about, mostly they complain about because other languages, they have it nice and we can't have nice things. So you see those, and but that's interesting. I think that important to find out that it's not a matter of, well, it was a bad decision back then and now we can just fix it. Both of those things are wrong. It was not a bad decision back then, and no, we cannot fix this in a way that really makes sense. So there were a couple of other interesting questions. One of them was, what is your favorite non-Java JVM language?
So that one's a pretty easy one, and that's Clojure.
Oh, and there's at least one person in chat who's going to be very, very happy with that answer.
And the reason for that is, I think Clojure is one of the few production quality serious JVM languages that isn't just, let's do Java better. In some sense, Scala and Kotlin are an attempt to retell the Java story with a more modern twist.
Yes.
And, that has some incremental benefits and it has some incremental costs. But fundamentally, both Scala and Kotlin have the problem that they're a lot like Java, but they aren't Java. Whereas Clojure is not trying to be Java. Clojure is trying to say, let's take a well understood programming model that has worked for 50 years, that is very, very useful for a lot of the kind of problems that we're still solving today, and let's integrate it nicely with the JVM and the JDK so that it is easy to consume libraries from the Java ecosystem. And I think there is a lot of leverage there. So it's definitely, like I said, it's something that's materially different from what Java is.
But that also sounds like if you were making a new language, then you would not actually be interested in just doing Java++, in just doing, okay, let's flip these couple of switches that we learned now that we're probably not, that we can now make different decisions on, and let's just do that. It sounds like you would be more interested in doing something that is categorically different.
I think so. I'm certainly having fun doing what I'm doing now. So it's not like I'm looking for a different language to work on. And I do think that there is a special challenge in evolving Java, right? That because Java is so successful for so long with so many developers, the constraints of evolving Java are particularly challenging. And, I think that, is, it's a noble cause, right? I mean, if you look at what we did with lambdas, right, a lot of people thought you're never going to be able to add lambdas to Java, or if you are, it's going to look nailed on to the side. And Java developers will never get used to lambdas. It's too weird and different a concept for them. And well, I think we did a pretty good job. And I think it looks like it was designed there almost from the beginning. And I think that is a particular kind of challenge that I enjoy tremendously.
And that's it. I hope you liked the video. If you did, make sure to like or subscribe or follow me on Twitter or, oh shit, how do I turn this back off? Oh my god, this makes it worse. No.